Hi, this is Miles Agnew from milesagnew.com, and in this video I'm going to explain a DNS, and more importantly Open DNS, and how you can use this free service to speed up your internet and also make your systems a lot more quicker in resolving domain names. DNS is the conversion of the domain name to an IP address. So you look at opendns.com. If you have a look in a DOS prompt and you go ping opendns.com, you can see it resolves to 208.69.38.160. So it's converted from a name to an IP address. That IP address gives it the location on the internet, and that, for example, this would be located in the US. You can tell by the first two numbers. And this is IP version 4. IP version 6 is a lot different, but for the sake of this video I'm going to keep it simple and use IP4. Okay, so what does OpenDNS do? OpenDNS is really a quick service, much quicker than most ISPs in Australia. For example, I've been with multiple ISPs, but I keep my DNS settings the same. Now, what DNS servers I use are these two. 208.67.222.222 and 208.67.220.220. What these two servers do, and you can point your router, your network card on your actual computer to use these IP addresses, is it updates regularly. So for example, if you're like me and you're doing a large amount of domain name adding and removing, it will update fairly instantaneously, whereas some ISPs such as Telstra, Optus, and some of the little providers that rely on Optus and Telstra's DNS servers could take anywhere from 3 hours to 24 hours to update their DNS settings, which basically means your site's not viewable until those settings are done. Now, I know a lot of people would like to know how to see how your site or how it routes, more importantly, how you from one ISP to another. So I'm going to quickly show you a website that also does DNS and does a trace route. Now, you can't do DNS without a trace route. And what I'm saying there is that the DNS converts the name to an IP address and then finds it. So if it is the incorrect IP address, it's going to go down the wrong path. So this will obviously explain itself further on. The website I go to is traceroute.org, and I mainly focus on Australia, but if you're in another country you can simply choose another country. You can also use looking glasses, which have ping and a few other resources, also route servers, BGP if you're using routing gear, certainly with Cisco, Juniper. If you want to look at BGP, I'll explain that in another video, but BGP is just a routing protocol that just speeds up the network integration of what path to take across the network. So here we go, we've got Telstra and Optus. I've already clicked on these and got them running in a tab. So in Optus I've just done a quick trace to OpenDNS, and you can see it's gone from the Optus network to San Jose level 3. Now these grey ones, or the stars here, just mean that firewall and they don't respond back to their routes, and that's normally done at edges of networks, and for various reasons. It could be a security thing, it could be a government owned facility, multiple reasons why it mightn't display the route. And as you can see, it goes all the way through. Same with Telstra. You can see that it starts at Melbourne, goes to Sydney, across the transit to Reach, that's Equinix data center in the US, hits a peer connection of Reach, goes to San Jose, and then finally to the actual facility where it's hosted. So that's a brief explanation on how DNS works and how you can use traceroute.org to test various sites. I highly recommend that you use OpenDNS. It's a lot faster and more reliable than your ISP's DNS settings, and you simply put these DNS settings in your router. If you've got an ADSL router, there'll be an option there, and most devices will allow you 4 DNSs, so you could add these two at the top, or you can just add one and then your ISP's obvious DNS. You always want to keep your ISP's DNS in there, just in case network connectivity to these particular hosts gets severed somewhere. And what I mean by that is, say there's a problem in the US or somewhere else and it affects your path to these particular servers, your local servers are going to respond and give you some sort of connectivity. So that's the idea behind it. Have at least 2 to 4 DNS servers, at least one with Open DNS, if not 2, and that will make your DNS obviously run a lot more quicker than normal. And also you can actually sign up and use free services, so you can actually do content filtering with these. This is great if you've got employees or families. It's a free service. You can buy the business and enterprise plan. I'll just quickly click on that and show you some pricing so you can see. The basic version has ad supported. So what that means is if you go to a site that doesn't exist, there'll be Google ads on it. And here you go, $10 a year for households. That's fairly cheap, no advertising. You can whitelist obviously sites, and you can see whitelist 50 domains, maximum number of networks 3, and obviously stats and all that sort of stuff, so you can actually see what your people are looking at. But more importantly, you can filter phishing sites. So for example, if you're going to your banking site and the IP address changed and it wasn't in Australia, this system would pick it up if it was doing some sort of phishing scam, because what happens is a lot of enterprises such as government, corporations that are aware of these things, they tell providers like Open DNS, antivirus providers, saying that this site's bad, and then it gets locked down fairly simply, and it'll come up. It'll still let you go to it, but it'll come up as a warning saying this may be a phishing site. So DNS is a very important part of the internet. It converts the IP address to name, and from name back to IP address again. So I hope you've enjoyed this video, and look out for more videos on the technical subjects. This is Miles Agnew from milesagnew.com.